sunlight per square meter at any distance. Okay. So, this is the brightness of the sun, right? Would you just look up?
Yeah, got that.
Or you can do, so that's the brightness of the sun. 4 pi r squared is the size of the sphere at a radius r. That's the surface area of a sphere at a radius r.
So the sphere in that case is the distance of each one from the sun.
The distance of each planet from the sun.
So in AU, you'd be using that as the radius?
As the radius, right. So you can stick in, and we can use it in AU because we're comparing them.
Yeah.
If I was asking for the absolute number, you'd have to use the radius in meters, right?
Right.
But we're just comparing the brightness at Saturn, not Saturn, the brightness at Venus to the brightness at Earth, right?
Yeah. So like for Earth, you'd use a radius of 1?
Earth, you'd use a radius of 1.
Okay.
Yeah. And Venus is at what?
Venus is 0.723.
Yeah, 0.7. Mars is at like 2.4, 2.5, right? And so you just stick, and things you can notice, right? That cancels out when you're comparing the two. Because when you're comparing the two,
What did you say cancels out?
the brightness of the sun cancels out,
Oh.
right? Because when you're comparing the two, you're looking at brightness at Venus divided by the brightness at Earth, right? To compare the two. And so, that is in both of them. So you get the luminosity of Earth, the luminosity of the sun divided by the luminosity of the sun, it cancels out. Does that make sense? So, for the purposes of this, right, what does this actually end up being?
Like 4 pi times 0.723 squared for Venus, right?
Right? So, we know that's going to go away because we're dividing this by that. And we know that's going to go away, but the 4 pi is going to go away because we're dividing this by that.
Oh, okay.
Right? The only thing that we have left over is 1 over r squared and 1 over r squared.
Okay, can you do that again? Go through that again.
Yeah. All right. Because we're taking the ratio to see how bright it is relative to the Earth, right? That means we're going to be taking this for Venus and dividing it by the same thing for Earth, which means the luminosity divides out and the 4 pi's divide out, and what we're left with is 1 over the radius at Venus squared divided by 1 over the radius at Earth squared. All right? It gets messy, but here it goes. Was that sarcastic? Now, you can just go through and calculate this whole thing and then take the ratio, right? That's fine. And if that's easier for you conceptually, just do that. I'm a math and symbols guy, so I tend to think through it like this and just get rid of everything I don't actually have to use. But I've had a billion years more physics than you guys. It seems like.
You just do the same thing for Mars?
Same thing for Mars, right? You just put Mars up here and do the same thing.
So really, once you get that result, you just divide the 2 to get the percentage.
Yep.
Okay.
Yep, that's all.
Okay.
What's that? Yeah, the ratio, right? Any other questions? Hey, late arrivals, let me know. And look at the whole and I'm going to post
Text and walk, it's a new thing.
It was 2 pages, so they just
Did I, Chelsea, did I send you a note
You did.
about chapter 5?
You said, not sure you turned in both pages of this homework.
Yeah, so, and I said that because you had the last problem,
But not the first.
but not the first.
Okay.
Which was a clue for me that you probably did them all.
So how do we go about fixing that?
So send me a note about chapter 2, look and see if you can find the rest of chapter 5.
Okay.
Okay?
I'll
All right. That's okay. Okay.
I'm here.
When you start to think about your problem,
Doctor.
Your,
Jackson.
ah! Okay. You can try and catch me while there's office hours. I'm also going to, I will publish solutions to the homeworks before the weekend. Even though you guys haven't done 90/10 yet, I'll still publish the solution to that, so you have all the homework.
they should be headed toward trials, find out what the new goals.
Yeah.
But it's like, I kinda got that one, you know, the other stuff is relatively easy, it's the only thing I think really getting me is trying to get the homework from there, you know, part.
Yeah. So, I'll get those solutions posted pretty quick. And so go through all the solutions. You know, I'll probably wait until tomorrow because chapter 9 is due today. Yeah. Today. send out a note, letting everybody know it goes to discussion. Okay? Any other questions?
That's what my dad asked, the front person, where's
Not yet.
picture going?
You say you can see,
What's that?
I think it was from your, what's the range you can see it from?
So we can see what,
She got this right.
oh, it takes a pretty good telescope to see it.
Graham.
We can see up through Saturn, but after that, you have to have a good telescope to see it.
What you mean, like, with binoculars, so far,
Binoculars, you can see, with binoculars, you can see the Ganymede, the Galilean moons of Jupiter. You can see Saturn's rings with really good binoculars. Now, that means, you know,
Jade's little sister, I think, and said her between.
ones that you would use for like,
She was trying to fold her hair.
oh, what am I thinking?